Hello and welcome to Rubber Quartz. Today we're gonna build a Squirrel 35. The hands you actually see belong to Patrick. He got a new cat, that's what they look like. Torn up from war. Now the tools you're gonna need is a Torque 6 driver. You're gonna need a normal hex 1.5, some wire clippers, a small Phillips driver for the O3 antenna. Tweezers are always nice to have. A wire cutter to separate the USB breakout board. And here it comes. Yeah, there was the cutter knife for the uninsulating the cables mostly. For the carbon pieces, we got 4 arms. They are prepared with the TPU on it. The pressure ring. This is the top plate with the LiPo strap already inserted. Take care not to lose the insert on the end so it doesn't slip through. So basically we prepare this for you if you get a frame kit. If you need to use a different strap, you just clip off the metal buckle and insert it. Here you got the plates for the front end and the booty. The countersunk pieces are on the outside of the belt. Some motors, of course. An RX, the cable's gonna be shorter than that. There are 3 obviously, and an AIO. I will gonna put the length for the power lead here. Now let's start with the bottom plate. Just put 10mm screws. We'll start by building the center section. It's easiest if you do all the electronics and soldering before you close the build, obviously. Those are rubber ducklings. Depending on what silicone dampers you have on your AIO, you will need them. If it's flats dampeners, if the gummies are a bit higher, so you have enough clearance to the bottom plate, you can work without those. It doesn't matter for the stack mounting. Those screws are plenty strong enough to not allow for horizontal movement. If you have problems to get those golden ducklings in, like Patrick here, you can pre-drill them to 2 mils or just use the Torque 6 is the perfect size. You can just drill them all out with your Torque driver. I can and will fast forward a few bits and pieces so you don't have to watch Patrick fumbling around getting the... Just to give you a general idea, it takes us about 1.5 to 2 hours to finish a build, so you should expect 2 to 3 hours. But this video will be a little bit shorter since I'm gonna fast forward redundant parts. Now that the stack screws are finally in place, we can place the AIO. Be aware if you use the Fenix AIO from our build kit or you bought it somewhere else, that you route the cable for the O3 under the AIO and that you de-pin the S-bus cable. And please don't deepin the second ground because the Fenix AIO recognize if there is a digital photix by the second ground cable. So just deepin the S-bus because the uart from this S-bus input is shared with the uart2 on top. The cable for the USB port. You can clip off everything but black and red is power, and I think it's brown and white cable are for the D plus and D minus for USB. You can also already put that in. Only the O3 cable will run under the AIO, so you should plug that in and bend it over so you can route it beneath the AIO. Make sure it's tight, we don't have a lot of wiggle room on that cable. Now you can screw down the AIO with the Nylock nuts, or just put a little bit of pressure on the rubber. With the Fenix, it works out that the top from the screw is flush with the top of the nut. Next we're gonna put motors on the arms. The arms come prepared with the TPU on top because we have to countersunk the center hole a bit because T-motor delivered us a slightly too big C-clip. And that's why we put the TPU on, so you don't mess up and down, because we only want to do it on one side. Be aware that Patrick here is building with the bundle kit, so those arms are 6mm wide and motor screws needs to be 8mm. Otherwise you just take the 6mm motor screws that come with the motors. Once you have all 4 arms in place, it's time to build the center section out. So we take the bottom plate with the pressure ring on top, have 4 arms, and we'll need 12mm countersunk Torx 6 screws. And here comes one of the trickiest parts of the build. You need to line up the pressure ring with both arms and then slide the 12mm screw in. Once you have it bite on the press nut in the bottom plate, those two arms are fine. You'll have to do it 4 times. Sequence doesn't matter. I usually start with the sides and then do top and front, front and back. And Patrick is going in a circle, but it really doesn't matter in which sequence you mount the arms. Now that we have the center section solid, we can start soldering the motors. For the lengths, I just cutting a bit over the fats. Patrick is lining up the cables and bending them how he likes them, and then cuts them exactly over the pad. I think my option is a bit faster because I just pull it tight over the fats and clip it like 2-3 millimeters over the fat, or at the border of the capacitors that sit close to the fat. Just remove about 2 millimeters of the insulation. This way you don't have unnecessary contact points. The insulation should almost touch your solder blob at the end. I usually don't use the wire cutters for this, but cutter knife, an X-Acto knife, and I roll it over my thumb with the cutter knife. Now it's time to heat up your soldering iron and thin those wire tips. Make sure you work with enough heat and proper rosin core solder to have the solder flow into your cable, so the end of your cable will get a little bit stiffer. As you can see, Patrick has already tinned motor pads in advance. They don't come like this. So take the tweezers, keep them in place. I usually put some fresh solder on the iron before I do a set of wires to have a little bit of flux on the iron. Just hold them perpendicular to the board, and it should be done in less than a second. Once you have it soldered and it's cooled down a little, you can sort the cables to have them sit neatly. Now that the motors are done, it's time to solder the receiver. This one is already prepared. Make sure the antenna is long enough to go out to the arm. The antenna is put in on reverse, so it's less strain in case you break the arm where the antenna is glued to. You don't need a lot of length. 2 to 3 centimeters should be fine. We will use the uart 4 for the receiver. It's right on the border of the board, starting with ground, 4.5 RX and TX. 4V5 means it's a 5-volt pad that is powered by USB, where the 5-volt pad directly above it is only powered via battery. And here we go, starting with the ground. Let it cool down before you release the tweezers. 5-volt, make sure this doesn't short to anything. RX goes to TX on the receiver and TX goes to RX on the receiver. You should know that. Now you can sort out your antenna, just push it through the arm. Fold in the receiver cables and push it in. I usually push the receiver under the motor cables, so I have an easier time when I have to change a motor later on, and the receiver gets a bit better kept in place by the motor cables. Now that all the electronics is soldered and the motors are soldered, we can finish up the midsection, and here comes the biggest pain in the ass, because you have to take the screws out in order to put the top plate on. And getting them in is a bit of a hassle, but it's manageable and you won't do that very often. Here is another part that I do slightly different than Patrick. I usually finish the front end with the camera and the booty with the VTX first, and those two TPU pieces that he's mounting to the frame, to the center section, I usually put them in the front and in the rear section where they belong. But this, what Patrick does here, makes it easier to slide the front and tail section in later on. Now it's time to take the arm screws out again. Just be careful not to upset the whole assembly. If you don't move it too much, you have an easier time to get the screws lined up for the top plate. Once you got everything out, try not to move it too much. Take the top plate. The part with the stopper goes towards the tail. In between the arms and the 3D printed part. Try to line it up by looking through the hole. You can also look at the holes over the stack screws. Once you got the first screw in, the others are quite a bit easier. Now that the center section is sorted, you have two options to progress. What I do is build the front end and the tail end completely separate and then just snap them in. The option Patrick here takes is to build it on the existing center section. Let's start with the first tail plate. Make sure the countersunk holes are pointing to the outside. The fitting of these slots is really tight, so we check every frame and grind them down a little, so make sure it slides in but stays tight in place. The easiest way to get this in is to point it slightly downwards and slide it in, and then get the bottom slot in by pushing it down. You do this with both plates. Again, the countersunk parts are outside. You hear it clips nicely in. Once both sides are seated, you can get the back arm screw in. Another approach is to have the front and the tail arm screw in before you slide the plates in, and have them just barely bite into the press nut on the bottom. Put in both self-tapping screws from the side. Now we'll get the O3 ready for mounting in the tail. Just tear off the stickers. Use the little Phillips driver to open the cover for the antenna connections. Make sure to don't bend up the UFL connectors. I usually use tweezers and push them under them and slightly pop them up. Now slide the antenna cables through the TPU mount, one after the other. You shouldn't need a tool to push them through. Can reconnect the antenna connectors to the O3. Make sure to properly line the UFLs up before you put pressure on it. It takes like less than half a kilo of pressure to pop it on. The antenna stems usually point a little bit inward so you can get the retainer back on. Now you can push the tail holder onto the O3. Orient the O3 so that the USB port and the SD port points upwards and the camera cable points forward, and then you can push the tail holder on top of it and slide one of those beautiful engraved standoffs inside. And take this whole assembly Connect the power and uart lines. Bend the cable 180 degree, slide it in and seat the O3 in the bottom front TPU part. Since there's so little wiggle room in that cable, especially some cables are 2-3 millimeter shorter than the rest, make sure they are properly seated on the side. Now you can close up those three with two of those countersunk 6mm M2 torque screws. You gotta tighten those two screws to make sure the TPU holding the O3 is properly compressed. To get the camera cable routed under the top plate, open up that arm screw on the side once more. You need to take it out to get the cable in. Use something to wedge the top plate up a bit, and then you can push the cable between the top plate and the arms. Now we can build up the front end. It's similar to the tail. Slide the vertical plates in. Make sure the countersunk holes point to the outside. Once the plates are in place, you take the last arm screw, the 12mm countersunk torx screw, and line up both front arms and close the deck with it. You don't need to pull them super tight, just make sure the fitting of the carbon plates is properly in place. Find the last two self-tapping screws, they're all the same size. It's M2 by 6mm with a Torx head, we prefer it. And screw the side plates to the front mount TPU part. For the O3 camera mounting, remove the screws that come with the O3. Those are a bit too long. We can't go all the way in because our front end plates are too thin for them. And use the two, I think it's 3mm button head screws we provide with the hardware kit. Be aware you don't need 4 screws for the camera, and you shouldn't use them. The cam is less than 10 grams, and one of those screws can easily hold 50 kilograms in any direction. And it makes it much easier to adjust your camera angle and position if you just use one screw per side. At this point, a small reminder for myself. Make sure you have the camera right side up, so when you look from the back, you can read the DJI logo. Depending on how much up tilt you fly, you now need to find your perfect mounting solution. For me, it's the top hole in the top slot. I fly 30 to 40 degree freestyle and 50 to 60 degree when racing. Just screw it in loosely in the slot that things makes the most sense for the up tilt you need, and make sure only the top and bottom lip from the camera cover extend over the carbon. So I broke those slips on a couple of belts, but I never had a dent in the lens. Now it's time to put those wedges in. They make sure the slots in the carbon stay properly seated. Do the front one first because it's much easier. The wedge goes between both ends of the LiPo strap, and you need to push it all the way into the carbon so it keeps properly seated. The tail one is a bit trickier because you need to slide it under the cables that go to the O3. Now pick 2 more of those beautiful standoffs and 4 of the short countersunk screws and screw them in to get the camera cage rigid. The last standoff is meant to be put into the USB connector and O3 holder on the tail, but Patrick will do the rear wedge first. As you can see, he's carefully pulling the cable for the O3 up and sliding the wedge under them. Here it is in front of the rear of the LiPo strap. Take care not to tear your cables while you push this in. Yeah, please use a hex or the Torx driver to push the wedge in. If you do it with the tweezers, you will punch holes into it. It won't matter for functionality, but you know what I mean. Yeah. This is better, much better. Yeah, push it in. Now slide the cables through from the bottom through the USB holder. You can, and I usually do this, solder it with the USB connector already pushed in the TPU part. Patrick is screwing the USB holder in place. I solder with the TPU extender pushed inside the TPU beside the rig, and then I put it all on top. There are lots of different ways to do this. None is worse or better than the other, whatever fits you better. The USB extender that comes with the Fenix AIO is combined with a breakout board for a low power uart and an E2C connector. We don't need this. I probably will never put compass on a Squirrel, but you never know. You just clip it. Since we are doing super clean builds over here, we file down the line where it breaks, but you don't have to. If you do it, and while you're sliding the USB connector into the TPU, be really careful, because there is a protection diode on it that is easy to tear off. Now carefully solder those super thin wires to the USB extender. The pinout is black ground, red +5 volt, then brown is digital plus and white is digital negative. Sort your cable properly, pull a little bit from the bottom when pushing it in, and be really careful not to push any pressure on this diode, because we already broken 2-3 of them. We are considering getting some special glue to keep that in place in the future, but nowadays we take just another USB extension or re-solder the diode when I break it. The LiPo-pad you see here is the newer generation. It's a little heavier than the two separate ones. We use it only on the bundle frames to give the battery a little bit more grip. If the battery pad is becomes too little sticky, just clean it with ISO and a soft cloth so you get all the dust out, and it will soften the material a bit, and it will stick like on the first day again. Now tape down your antenna wire and the antenna. Make sure you put the receiver in place and route the antenna wire in a way that keeps the receiver a bit in place as well. Helps, otherwise the receiver slowly starts sticking out, especially when you put in above the motor cables like Patrick. And that's it. I assume you're capable of screwing screws out without instruction. We prefer flying props out because it doesn't throw you that much dirt into the camera. But in a build as powerful as this, it really doesn't matter. Have fun building it for yourself.